Here we go. Okay, so I just did that. So here, basically what's happening is I'm telling you the output is 2. We want to know what the input is. So if the output is 2, so we know the function gives us back 2. What input gave us that? What was the input? Well, f of x, right, is 8 times x plus 9. So really what we're saying is we want to find x so that 8 times x plus 9 equals 2. So now again, it's just basic algebra, right? We want to solve this for x. And that's what I'm doing here. You know, you want to get x all alone. Right? So we have 8x plus 9 equals 2. So we subtract 9 from each side. Right? We get 8 times x is minus 7. Okay. And so from here we have 8x equals minus 7. Right? I just brought the 8x a little bit closer. So we want to get x. We don't want 8x, so we divide by 8. And we get x equals minus 7 over 8. That's what we get. So this is telling us if our input, so if we put into the function negative 7 over 8, we will get 2 back. That's what this is telling us. Good. Let's do another one. So this one's a little bit different. Instead of 8x, wait, hold on. Instead of 8x, plus 9, this is negative 8x plus 9. So the only difference here really is we're multiplying by negative 8 and then adding 9. All right. So again, let's evaluate functions. We're going to evaluate f at 2 and f of negative 1. So we're evaluating the function at 2 and at negative 1. Okay, so what would f of 2 be? Well, again, we're replacing x by 2, right? You know, our function's given by a formula. We're going to replace x by 2, and we're going to get negative 8 times 2 plus 9. Negative 8 times 2 plus 9, what is that? Negative 16 plus 9, which is negative 7. That's what's happening here. So if the input is 2, the output is negative 7. If the input is negative 1 now, okay, if negative 1, so here we're looking at f of negative 1. So if the input is negative 1, then the output is negative 8 times negative 1 plus 9. Right? So again, if we put negative 1 into our function, what are we going to get back? Well, negative 8 times negative 1 plus 9, which is 8 plus 9, which is 17. That's what we get back. Okay, so just like before, let's evaluate a function, let's solve an equation involving a function. Okay, so let's do that again, solving an equation involving a function. So in other words, here I'm saying we know f of x is 5, let's find x. So we want the input so that the output is 5. That's what we're looking for. Okay, well, we know f of x is negative 8x plus 9. So we want to solve this equation for x. So let's do it. We subtract 9 from each side, right? Because you want to get x all alone. Subtract, we get negative 8x is negative 4. Okay. Negative 8x is negative 4, right? I just brought that closer. But again, we don't want negative 8x, we want x. So what do? Divide. We get x equals 4 over 8, Well, I mean, excuse me. If we divide by -8, we get -4 over -8. But again, by our sap and sun rules, that's the same as 4 over 8, which is a half. So that's what we get. Okay. All right, so that's good. All right. Oh, sorry. Any questions on this? For some reason, I thought there was another example, but that's okay. Do you have questions about this? Okay. So we saw some ways to represent a function. We saw, okay, you can represent a function by a graph. You can do that. You know, if f were the function, let's say, the idea is that in the Cartesian plane, each point, x comma y, right, that's on the graph of the function, satisfies this, y equals f of x. So every point on the graph is of this form. The idea is that x is your input, y is your output. So the x coordinate gets mapped to the y coordinate. Input goes to output, which is equivalent to saying this in terms of our notation. I mean, really, what is the graph of a function? It's the collection of all points of this form. So you're showing all the inputs and the corresponding outputs as points in the plane. That's what you're showing. Okay. And I did show a graph here to illustrate that. I mean, I tried to represent this here as b comma f of b, you know, just to illustrate what a general point on the graph looks like. Okay, so I probably should have taken these numbers away here on the axes, but hopefully you still get the idea. Sure. And this will come in handy a little bit later. You can think of the y coordinate, right, as your height above the x-axis, right? To get to a point on the graph, you go to the x coordinate. Excuse me, if you're at a point on the graph, right, and you want to get the y coordinate, you just move horizontally to the y-axis. You just move horizontally to the y-axis. Okay? And again, that tells you how high above or below the x-axis you are. That's what the y coordinate tells you, your height. Okay? Good. And you could also evaluate a function using a graph. Let's say we wanted to know what f of 1 is. Well, we go to the horizontal axis because that's where the x lives. Actually, you know what? Let me label that just to make it a little bit easier. Here's x, the x-axis, and this is the y-axis. When we have a graph, unless stated otherwise, the horizontal axis is the x-axis, the vertical axis here, that's the y-axis. So if, let's say, we wanted to know what f of 1 is, we locate 1 on the x-axis. And then what do? We go up or down to the graph. So we're going to go up to the graph in this case, and we're going to move over horizontally to the y-axis. So again, what do? We go to the x value. We're going to move vertically to the graph, in this case up, and then we're going to go we go horizontally to the y-axis. That's what we do. So f of 1 here would actually be not quite 1. It would be a little bit less than 1. If you were to say, to consider, I don't know, f of 3, well, again, here's 3. We go, in this case, we're going to move vertically to the graph. And now we're going to move horizontally to the left to get to 2, as you can see. So f of 3 here would be 2. So since 3, 2 is on the graph, f of 3 is 2. Okay, this might make more sense. This is a different graph. Notice here the point 1, 2 is on the graph, right? As we can see, 1, 2 is on the graph. That's labeled. So that tells us that f of 1 is 2. As another example, f of 3 is 2. Since 3, 2 is on the graph, right? F of 3 is 2. And of course, f of 2 is 1, since again, 2, 1 is on the graph, right? I mean, here it's labeled 2, 1. So, good. Are there any questions about that? So here's another example. Here, let's say this was the graph, okay? What would f of 0 be? Well, f of 0 would be 3. Now, why is that? Well, if we locate 0 on the x-axis, we're going to move to the graph vertically, so we're going to move up, and we can see that we hit 3 once we hit the graph, right? So again, f of 0 is 3. We locate 0 on the x-axis. We're going to move vertically, in this case up, to 3, to the graph that is, excuse me, and we're at 3. So f of 0 must be 3, which means 0, 3 is on this graph, the point 0, 3. Let me see if I can draw that. So this is 0. Okay, bear with me. So this is the point 0, comma, 3. There we go. Good. So 0, 3 is on the graph. Okay, that's what we get. Notice also, even though I didn't ask it, we can find f of 1. Where's 1? Well, we locate 1 on the x-axis. Ah, here it is. Notice we're already on the graph, so we don't move vertically at all. So f of 1 has to be 0. F of 1 has to be 0. And so does f of 3, right? F of 3 also has to be 0. Right? Because again, once you locate 3, well, you don't have to move vertically at all to get onto the graph. You stay on the x-axis. And again, unless stated otherwise, the x-axis is always horizontal. Okay, I was going to let you guys try this, but f of 1, I said what that is already. F of 1 is actually 0. I didn't take the solutions. Okay, well, f of 1, I'm telling you, is 0. F of 2, what would that be? Well, again, we're going to go to 2. Here, we're going to move vertically down because the graph is below us. So we move vertically down, and then we move, and then we have to look at the y-axis or move horizontally. We get -1. So f of 2 here is -1. Actually, you know what? Yeah, let me write that. So f of 1 is 0, and f of 2, as I just said, is -1. Okay, you have to stop. Okay.